As a matter of fact, from this point on, we are recording the session. Okay, so let me go ahead and share my screen this morning, and we'll get going with our HMH school only application.
No.
All right, so this is going to be cool only, guys, in the HMH.
That is correct. That's what you wanted us to do, right, Ty, today?
Yeah, so basically, they've already installed 3,
5, let's say. It doesn't really matter.
They put in several. So basically, what we need for quality is an overview, just the cool only setup, because I don't think they've done a cool only yet. A 3-wire. They've done the 5-wire. So basically, going to be just a real quick overview, and then they got some questions at the end. This is all the installers, and they just got some
variable speed air handler or not.
Yeah, it basically just to do the overview on the variable speed versus the AE.
Well, actually, the program, I went ahead and did both because I wasn't sure if that's okay. We'll just review both if that's all right.
Yeah, that's fine. Just get them the knowledge they need to put them in regularly.
Okay, you got it. All right, fellas. Well, good morning. So just a quick reminder. I know you guys probably already know this, but just a quick reminder, make sure you've got that 5/16 by quarter adapter so you can get your service hoses on the thing. You're going to need that because it's a 5/16 flare on the unit. And then I like to remind everybody real quick also, excuse me, that on the platform, the single fan units are going to be the 2 and 3 ton unit, and then the 4 and 5 ton unit will also be the double stack or the double fan model. So guys, this morning we're going to be discussing that low voltage wiring and setup of the HMH heat pump in a cool only application. So this is kind of a unique application. And so we're going to be talking specifically drilling in on the AE air handler and the variable speed air handler. And so we're going to be talking about that wiring accessory kit, that 001. Now, I know once you guys wrap your heads around this. Fellas, we're getting a little bit of an echo back there, so go ahead and let's have everybody mute, and then if you have a question,
Chris, be quiet.
Hey guys.
Everybody good? Okay, that's better. Thank you. All right, so we're going to be doing the wiring accessory of the 001 kit. Now, this kit comes with all the parts inside as far as the relay and the bi-flow filter dryer and stuff like that, if you guys already have installed some of these. The other thing I want everybody to wrap their head around, and this is really, really important, in a cool-only application, you're going to use the 001 kit. Now, this is totally different than what we've done on other variable speed products. So just remember, on cool-only application, all you need is the 001 kit, even on the variable speed products. So kind of wrap your melons around that a little bit this morning. We're going to be talking about a standard 24-volt heat-cool thermostat for the control. And remember, if you do have electric heat, installed, if you've got a heat strip installed, you're going to have a thermostat that can be configured for electric heat. But you guys probably already know that, but just wanted to make a real quick reminder for you this morning. Okay, on the AE air handler, now remember this has got pigtail, it has pigtail connections. So the block wiring diagram that we're looking at right
Joel.
Here. Yes.
Joel, we got a question. Hang on one second.
Go ahead.
So a question on the thermostat.
Yes.
So what they normally use is a TH4. It's a one heat, one cool.
So it's a one heat, one cool heat pump.
Yeah, one heat, one cool heat pump.
And in here we have auxiliary, we have E, we have OB. I mean, there's a way to wire it, in my opinion, this thermostat.
So basically what their question is do they have to use a 2 heat, 1 cool conventional, or can they use the standard 1 heat, 1 cool heat pump thermostat?
That's a really good question. It depends on how many stages of heat strip you have.
Which is always one stage until you do the 4 or the 5 ton, and then you would do a 15 kW. Other than that, they use basically a 5, an 8, and a 10, which is one stage.
Okay. So what we're going to be talking, so this little block diagram presumes 2 stages, but if you don't have, for instance, that second stage, if you don't have a 2-stage heat strip, just ignore that W2. Okay. So basically, that W2 will not be utilized because that's going to be your auxiliary heat second stage.
Second
So really,
stage, correct.
so really, what you guys would do, you'd have W1 or just W auxiliary heat over to your air handler to W1 or to W on your air handler, just like you see on the block diagram. Yeah. So that's a really good question. I just, when I built the PowerPoint, I presumed you were going to have a couple stages, but if you don't, if you have just a single stage, then a single stage heat, single stage cool thermostat that has electric heat capability is all you're going to need.
Yeah,
Good.
very rarely. I mean, if any, they'll use a 13 kW or a 15, which is a 2-stage heat strip.
Right.
Where we are, everything is kind of set up for straight cool. Where anything south of Port Charlotte, there is no more heat pumps.
Okay.
Everything that we're taking out is a straight cool system, and that's kind of why we're interested in this cool only application for wiring the condenser and using the air handler as a traditional. They turn the heat on and the 10 kW heat comes on.
There you go. Okay. Yeah. So basically on this block wiring diagram we're looking at, just ignore the W2 and just use that single stage auxiliary heat input for that heat strip. Good question. Then fellas, what we're going to do, we're going to take Y outside. That's our compressor call from our thermostat, straight outside. And then 24 volt common will go all the way through like you normally would. So you have a yellow and a common outside. Now that R terminal, a 24 volt hot from the thermostat goes strictly to the air handler. It doesn't even go outside. So that's pretty cool. And then you've got a G call on your thermostat over to your air handler. Now what we normally ask you to do on a G only call, normally what you're going to do, you're just going to take that G call and put it on the lowest speed tap on that high efficiency ECM type of motor. And that way, if the homeowner goes over to the thermostat sub-base assembly and they switch the fan from auto to on, they're just circulating fan at the lowest speed. In case they've got some, good air filtration devices, or they just want to move the air in the home, and a G only call. So select that lowest speed tap on that motor for the G only call is what we recommend. Then what you're going to do, you're going to have that S1 output. So this is a 3-wire hookup outside. You're going to have that S1 terminal outside coming in and hitting one side of the relay coil on your coil. So you're going to have this little 24 volt coil, single pole double throw relay. So one side of that coil is going to hit that S1. The other side of that relay coil is going to go up and hit common. So basically, anytime we have an S1 output from the outdoor unit, now what this is for reduced airflow. That's the whole idea behind it. So you got 3 wires outside, and that S1 is going to be commanding reduced airflow. And here's how that works. So on the unit itself, or on the relay inside the air handler, you're going to grab that yellow wire that you're going to take outside, and you're going to bring it down to the common terminal for the switching contact. So we're feeding 24 volts to the common switching contact. And then on the normally, before we do that, let's go ahead and grab the high speed tap. Just a quick reminder, take the high speed tap on that ECM motor and go up and hit it so that whenever you have a heating call, an auxiliary heat call on that W, we're going to drive that motor to high speed or close to high speed. That way you don't overheat the heat strip. And then on the normally closed contact, of that relay, you're going to come over and you're going to grab a speed tap on that motor. It's going to give you 100% cooling airflow. Now, fellas, remember, we always want to set our airflow up for 400 CFM per ton of cooling. So if you've got a 2-ton unit sitting outside, what you're going to do, you're going to set up this normally closed contact and grab a speed tap on that AE air handler, that indoor blower, that high efficiency blower. You're going to grab a speed tap that's going to give you 400 CFM per ton. So if I got a 2-ton unit out there, I need 800 CFM. If I've got a 3-ton unit, I need 1200 CFM. You get the idea. So this is your high speed cooling airflow on that normally closed contact of that relay. Then on the normally open contact of that relay, you're going to go over and you're going to select a speed tap on that motor. It's going to give you about 60% airflow. So here's the idea. When the outdoor unit switches that relay and calls for reduced airflow, it's going to switch that relay and it's going to call for that lower speed tap, about 60% airflow. So if I got like a 2-ton unit a 2-ton unit, and I need 400 CFM per ton for high-speed cooling. 60% of that's going to be about 480, 450, 500. You cats get the idea. So we want that reduced airflow when the outdoor unit starts modulating back, because remember, guys, that outdoor unit's going to modulate between 35 and 100% capacity. And so when it starts modulating back to about 60%, 55%, 65%, you guys get the idea. It's going to energize that S1, switch that relay, and drop the airflow back inside, so we have some nice humidity control, and the airflow is now matching, pretty closely matching the outdoor capacity. That's why we have that relay, is to switch that airflow. And so really provides a really wonderful level of comfort. Now, I had a couple questions. I want you guys to please remember this, that even though this is a straight cool application, 2 things I want you to really wrap your head around. Number one, you want to make sure and use that bi-flow filter dryer on the liquid line. The other thing is make sure that the coil that you install inside is heat pump compatible. In other words, it's got a bi-flow TXV in there. It can be used for heat pump or straight cooling, either one. Most evaporators are set up that way anyway anymore. But make sure the indoor coil is a heat pump compatible coil, and that you use a bi-flow filter dryer. And here's why. Because occasionally what happens is that outdoor unit has a program in there, I believe, to where it's going to exercise the reversing valve, just to make sure that it doesn't get stuck and all that kind of stuff. So if we exercise that reversing valve, even in the dead of summertime, if we exercise that reversing valve for 5 seconds or 10 seconds or whatever, we want to make sure that we don't have a refrigerant blockage, because we didn't put a bi-flow filter dryer on that liquid line. In addition, same thing on the indoor coil. If we exercise that reversing valve even for 10 seconds, we want to make sure that that refrigerant circuit can have that bi-flow capacity, just like a heat pump. Does that make sense to everybody?
Yeah, which all of the units that they put in are the ones we supply, so they would all have that coil already set up at TXV.
There you go. I just wanted to make sure everybody wrapped their head on that. Even though it's straight cooling, we still want to use those refrigeration components in case we exercise that reversing valve. Good.
If you want to take a picture of this, let them take a picture real quick, Joel, of the schematic here real fast, just so they have it.
Absolutely. Take a picture, and we'll talk about variable speed air handler and a few airflow considerations.
Again, this is your cool only with the AE air handler. I know you got one.
Oh, you got it?
I'll send you.
All right. Everybody good? Anybody have any questions on this setup? I mean, it's pretty cut and dry. I mean, 3-wire.
So what is our difficulty, guys, when we're out there in the field? Is it more so wiring the condenser outside?
I mean, the biggest problem is they've never seen it, and when you actually look at this, it's not a simple. People that don't read schematics every day, you look at this and you're like,
absolutely.
Why are you jumping from a relay?
What happens is
this
this right here is what the condenser looks like.
That's a condenser.
And this right here is what the air handler looks like, but we weren't getting this board, the HMH conversion board for the straight cool. So we're looking at a W1, W2, YCRG air handler and trying to figure out what letter matches B, C, S1. That's
I got you. So here's our 3 points, guys. So yellow goes straight across to yellow, of course. Common goes straight across to common. The only other one is this, basically a signal or a power wire to S1 that coming from here.
Now remember, guys, you were putting in the AVC, which is different than the AE, which is what Jacob said he wants from now on.
And we're gonna talk about
why would we call this common and then go to A, and then this is our common here?
That's all the yellows go together and all the blues go together.
Yeah.
It's just your colors. Don't worry about what it is.
It's color coded on that.
Beautiful.
that A and B is just the coil. That's just the coil voltage on that relay.
Don't look at common and hook common to common.
All right, so basically outside, that only extra wire is going to this guy. It's a
signal.
signal wire to that one that has a jumper on it.
Correct.
The jumper also needs is this like a? How are we doing this? Just we're wiring it and all 3 together?
Yes.
Yeah, it just hooks into it.
Okay, that's fine.
Yeah, in case it said that on the far left will be your thermostat. Your air handler's in the middle.
Okay.
So,
Yeah,
so you got
so
thermostat, air handler.
Here's your
outside.
thermostat here. Here's your heat pump outside. Here's your AE air
And
handler.
don't worry about W2. Focus
There
on
you go.
everything else.
Yeah.
Good, good.
Everybody good?
Wire never. Yeah.
So just to confirm, anytime that we're doing this and we're not wiring it up as a heat pump, I can use my traditional thermostat.
Yes.
Your regular
Our
TH.
thermostat should be
Okay.
on a heat
Yeah,
pump
because
as
you're
well.
you're losing W2. You don't even need it.
Well, just so everybody's on the same page, including the person that's on the other end of this line, we're doing HMHs because we can't get the TC7s. So
Yes.
we're not exactly pushing these HMHs necessarily, but we're relying or falling back on them when we don't have our material.
Okay,
So
that sounds good.
everybody's used to our TC7s and our TC4s, and it's just a normal wiring install. Our issue came into play when we ran out of stock and we can't find that piece of equipment, and then we're falling back on these HMHs to get a unit.
Yep.
So
Well, and the
we're
other
always going
thing,
to be doing it straight cool. We're never going to wire it up heat pump unless I'm in some kind of one neighborhood out of Naples that
Okay.
has heat pump.
well, the other thing too, guys, just for the from an application standpoint, and I live over here just south of Mobile. And so what I like about this unit is the fact that it'll modulate and give me a lot of extra comfort over the TC7, which is just a single stage. It also gives me the ability to reduce the airflow when it's mild outside, or once I have, conditions met inside, I can modulate back to 60, 65% that you can't do with the TC7. So this thing should give you a level of comfort in application that you would never have with the TC7 single stage. Just something
Well,
to think.
I'd like to touch on that too. Down here in Fort Myers and Cape Coral and Naples, we're piping hot, and our customers, I would say 80% of them, they want to feel the air, especially in the master bedroom. They want that air blowing on them. They want to feel it blowing cold. So the only thing that my next question is let's say I want 100% of my cooling airflow. It's just our speed tap and the air handler, correct?
Yeah. So let's say, for instance, you wired this up with just 2 wires outside. What would happen is you wouldn't have that airflow reduction. But what's going to happen? If it's mild out, let's say you have an 80-degree rainy day outside. It's real humid, and if you don't have that airflow reduction, your humidity control is going to go in the toilet. So that S1 wire and that relay, that airflow reduction, it's all about comfort. It's all about humidity control. It's all about yanking the humidity out of the air when it's mild outside, especially because you guys know this as well as I do. The worst thing that can happen is when it's cool and raining outside, and the thermostat's satisfied inside, and it's just kind of sticky and clammy, and nobody likes that. And so this is a real humidity eating champion compared to a single stage product. So just kind of think about that a little bit when you're talking about it and thinking about it.
Well, what happens if we do it at 100%? It loses the humidity control altogether. If we have all 3 wires outside.
No. It just won't.
No, it's not gonna lose. You won't lose all your humidity control. But what I'm going to ask you guys to do is that if you're stuck with 2 wires and you're not going to use, if you just can't use that airflow reduction, then go ahead and set your airflow up to maybe 350 CFM per ton instead of 400. So reduce that airflow a little bit during cooling.
So you're telling me we can wire the condensers with 2 wires?
We've had some contractors do that. We don't recommend it, but we've had some contractors do it, and then just reduce their airflow a little bit inside to help humidity control.
Well, I'm only asking because let's say in my last job, my last HMH, we had 8 wires outside and 5 of them were bad. So
okay, well,
five of the wires had been shorted out because of rain or it being exposed to moisture.
Sure.
And then we were only left with 3. And then some of my applications, where we're going out to, these situations where we're pulling out a 15-year-old system, and it only has 2 wires outside because we're not set up for heat pump here. We're only set up for straight cool. So some of my applications, sometimes they're only going to have 2 wires. So basically everything is the same, except we drop the S1.
That is correct. And just remember, because you got a modulating unit outside, if you have to do that, we don't recommend it, but if you have to do that, then screw your airflow back inside to about 350 CFM per ton to give you that little extra humidity control. And the outdoor unit, by the way, if it sees on the refrigeration cycle, if it sees all that airflow, what it's going to do is go sit here and modulate more towards its upper end most of the time, if that makes sense.
Yes, makes total sense.
Yeah.
Everybody clear on this one? Everybody understand?
You have no choice. And they got that option.
We're wiring W1 into the motor. Is that just wiring it all three together? Basically?
Yeah.
Or is there a terminal that we can kind of hook up to?
It's wired. No, it's wired.
Okay, so we're wiring it and all those together.
So yeah, if you have got
Are
two
they all
wired-
white?
I honestly don't remember, but it comes right off of it. Like you can,
You can see it on the motor.
Yeah,
what
it's-
wires.
Well, there's
what.
only one coming
yeah,
off.
once,
they
once you're in
disagree,
front of
but-
it,
And guys, remember,
Yeah.
remember something too, on your HMH7 001 kit that comes with the biflow filter dryer, it's got some harnessing and stuff in there as well. So you've got some wires and stuff, in that kit. It makes it convenient for you. That way you don't have to make up a huge amount of field wiring.
Everybody good? Jacob, do you want to talk about the ABC? I know you don't want to put that one in, but
Well, what, basically just, I need to know what the difference is.
so I mean, Joel, can you go to the ABC real quick so they can get So here's your cool only with the variable speed air handler, like you.
All right, so there's a couple little things about this that we'll breeze through the low voltage wiring. The big thing is on the ABC air handler, you're going to have a little control board up there near the airflow jumper or the airflow settings, right? And one of the big thing is there's going to be a jumper that says AC and heat pump. So make sure that jumper AC and HP, that AC and heat pump jumper, it's on AC, because what that will do, it'll tell the air handler that it is not hooked up to a heat pump. So you want to make sure that that jumper is on AC, and then after that, it's real straightforward. You still have the relay and all that stuff, but it's the 001 relay. It's the same relay as the AE air handler we just talked about. And when you go to wire the thing, you're going to wire it essentially the same. If you got a two-stage heat strip, W1 and W2, Y goes outside just like before. These 24 volt common all the way through just like before. R and G are the same. And then you're going to wire up that relay same way. One side of the relay goes to common. The other side goes to S1. Okay.
Say we don't have two stages of heat. We're just ignoring W2, correct?
That is correct. There you go. Same routine. If you don't have two stage of heat, you just ignore W2. You're still going to grab that yellow wire for the common switching terminal. Normally closed is going to go up to Y2 on the variable speed air handler, and then normally open is going to go to Y1. So it's basically real straightforward. And guys, remember, on the variable speed air handler, you've got a lot of options on airflow by those jumpers, or you take those jumpers to set your airflow up.
Basically, those ones that you're going to Y1 and Y2, I believe they're both black.
Let them get
They're
it. They're
still
gonna take
coming off
pictures
the-
of this screen.
No problem.
It's still same thing. The only thing you're adding is
That's the only thing that's different is that
Y1,
you're going to have wide one,
Well,
an
that-
extra Y.
and you have to take your prong off, and on the outside you have two separate dip switches. Your second set, you have to go to number 2, and you have to turn it on to tell it's cool. It's on the outside, but it's on the board. It's on,
Yeah, it's on the board in the
actual-
condenser. Yeah.
What you guys have
As soon
wired
as you
up so
take the
far.
door off, it'll tell you dip switch is factory off.
Yeah.
Cool only. Number 2 is on.
This is what we
Okay.
needed to know.
Yeah,
Just
I've seen
follow
that. I've seen that on the last one I just put in that Mason went back out to.
Yeah, just follow.
And like I said, guys, remember, on the AV air handler, or on the variable speed air handler, you're going to set your airflow up with those jumpers. So if you want 400 CFM per ton, or on a 400 CFM per ton. The other thing I want you guys, did everybody get a picture of this real quick?
I've got a picture. You good?
Yeah.
Okay.
All right. So when you, on this one, It's the same routine. When you energize that S1 terminal, look at that animation. When you energize that S1 terminal outside, bang, we switch that relay and we go to low airflow. In addition, give me just 2 seconds to back up to that little jumper board again. On that little jumper, that airflow jumpers, you got those airflow jumpers, heat, cool, delay, and adjust, right?
Yeah.
So those airflow jumpers, you can, look at your install information, but the cool and the adjust jumpers, they allow you to set up your airflow, right? As far as 400 CFM per ton based on the outdoor unit. Now look real close at the PowerPoint. You see where it says delay, that delay jumper?
Yep.
That delay jumper is a cooling on delay that'll ramp that fan for different parts of the country. Now write this down, burn this in your brain. If you take that delay jumper and put it on B, B is humid. B is for a humid profile. So between that airflow reduction.
For on this third one that says delay, we need to put that jumper on B.
On B terminal. Now watch this. Between that delay jumper being on B terminal and your airflow reduction with S1, man, you've got a humidity eating machine here. Big time.
So I would suggest if you do that though, make sure you, if you can, utilize a humidistat that's in the controls. Because the homeowner's going to have to adjust how much humidity they want, or else they're going to dry their house out inside.
Okay.
Just
Now,
be careful. Of that.
The only difference is the jumper between common and normally open, and the jumper between common and normally closed.
Comes right off the floor. It's very easy. It's not.
There you go.
If you put in
right on it.
if you put in an ABC and the homeowner wants humidity control, they want to be able to control that, make sure that thermostat has humidity control on it.
Okay.
So
Yep.
basically, all this needs to be with the Honeywell 9000.
Yes.
If you want the
Okay.
humidity control.
Because to Ty's good point, with the variable speed air handler and that delay jumper set on B, that humid profile, and this airflow reduction scheme we have with this relay, of all the comfort systems that you can put together a design, you take this HMH7 with a variable speed air handler wired up just like we have. And look, guys, you still only have 3 wires outside, and utilize that delay jumper and set your airflow up like that. I mean, you can literally drive the humidity down into the 40%. I mean, humidity eating machine.
This is going to require a 2-cool.
That would. You would have to have the 9,000 or an 8,000, 8320.
So a
Yeah.
2-cool with 1 heat would
Yes.
work for us.
Yeah, still. Yeah. But just make sure it has a humidity control on it.
Okay.
So they can put it where they want.
Everybody on the same page with this. If we have an AVC and that's the variable speed air handler, we need to make sure that you bring in a special thermostat. If it's the AE, which I've instructed Ty that that's what we want to order, we got to use our normal thermostat.
Yeah,
There you
so
go.
If the sales guys sell it as an ABC, that would tell me that the homeowner wanted.
The sales guys are, I mean,
And
we're not going to sell it that way. I need you to make sure, remember, we're trying to do this because we can't get TC7 or TC4. This is our backup option.
And fellas, the other thing is too, remember, and Ty knows this, but this goes for everybody on this call, and Billy and your crew and everybody. Guys, anytime you get into a situation that you just want to talk about it or have one of these team meetings, or you want to give me a call, please call me and we'll just go over whatever special application you want, one-on-one if we need to. It's anytime, any place, anywhere for you guys. That's what we're here for. That's what we're all about. Okay.
We appreciate that.
Yes, sir.
Thank you.
I think this answers our questions. Anybody got any questions before I send you guys out of here?
Anything at all.
Everybody good?
Something that you ran
It's much easier
into.
when you're in front of the air.
And you guys-
Yeah, that's what I'm over here. Like I'm
Don't
looking at
let
the
it
picture,
scare
but
you.
it's like I need an air
a
handler.
couple things.
It's all
Just real quick, Joel.
Yeah.
very self-explanatory.
So I've been out on a couple of the jobs with these guys. One of the jobs I was at, where the line set and wiring comes in the bottom of the unit, there's not enough wire length in standard SWIPs. So we've had the guys have ran this where basically went a little bit higher and drilled into the condenser itself, mounted their whips a little bit higher because of the wiring links.
Okay.
Is it that outdoor cover that comes on? Is they could put that anywhere, correct? Or do they even have to use that outdoor covering?
That covers up the line sets?
Correct.
The only reason that's there is just, I think more than anything, it's cosmetic. As you guys well know, some local codes too also require to have those refrigerant lines
Sealed, yeah.
Well,
covered.
not to interrupt, Joel, but Ty, are you talking about the composite plastic cover that
Yes.
covers the lines? Well, that's, but are we talking about line voltage coming into the unit?
Then we have line voltage coming in right there.
Because the line voltage comes in above that on the top. It does not come in where the lines come in.
Yeah. So the line voltage, the refrigerant line, everything comes in right there at the bottom of the unit.
Well, no, the line voltage comes in. You'll see there is a, Joel, do you have a picture of the unit in your presentation?
I do. Hang on. Let me go back to slide number 1.
Okay,
Yeah,
so
I'll come in at the bottom.
no, so if you look at that unit there, you see that on this, okay, so on the 4 and 5 ton, yes. On up to 3 ton, the line voltage comes in up above there, you'll see. Yeah,
Okay.
so,
Yeah, so we were doing we were doing 4 ton units.
okay, yep.
So the cosmetic cover though, right there on the bottom, is that that's just a cosmetic cover that if they don't use that, they just need to have the locking caps on it and make sure it's sealed, I'm assuming.
Yeah. And so basically, again, depending on your local codes, you could leave that cover off. It wouldn't hurt anything. It's just a decorative color cover to make it look pretty and all that kind of stuff. But I mean, some local inspectors, they'll make you put that cover on. So it really depends on your application. But from a functionality standpoint, it doesn't have to be on there for it to operate properly.
They basically just put punch outs up here.
Yeah. What we're trying to do is we're trying to accommodate them with 8-foot whips instead of 6, 8 or 10. Getting
Okay.
those is virtually impossible right
Compressor
now.
is right here on the other side.
Yeah.
So even if you have a 3/4 inch whip. these
So
are
they
all
had to
nothing
make an
bolts, so you can't
adjustment
even-
for
You
it
can't make
into
that
the
hole
unit.
any bigger because you'll hit the compressor.
Um,
It'll do it.
So are you saying that your solution is to, you're